morning everyone, Dr. Nat here. So we are going to cover chapter 2.2, which is graphical representation of motions. And we are going to take a look at our first graph, which is the displacement time graph. So from the name itself, we can already tell, oh, displacement should be in the y-axis and time should be in the x-axis from the name. I haven't looked at the graph, I'm just looking at the name, I haven't cheated. Okay, so now I'm taking a look at the graph. So from the graph, I can see that, oh, the y-axis is in displacement and the x-axis is time. I can also write it like this, displacement, okay, forgive my handwriting, in meter, which is the units. Always put in your units. And I can write this as time, which is the full name for t, which is in seconds, right? Or you can just label it as x in bracket meters and t in bracket seconds. Works either way, both are correct, right? The only problem is when you don't label it, then I don't know what you're doing and I can't give you marks, and the end. Okay, let's continue. So the information that we can get from this graph is displacement, average velocity, and instantaneous velocity. Let's take a look on how that is possible. Next page, please. Displacement is obtained from the final position to the initial position. We have learned this before, whereby displacement is, the change in displacement is x final minus x initial. Okay, you can also write it like this, or you can write the full name. And then average velocity equals the slope of the line joining the initial and final position. It's the slope. So let's say I am a ball, okay, and I moved from point A to point D. So my final displacement is D, right? And my initial displacement is at A. So D is at 0. So D is at 0 and the time is at 30. So I'm just going to label this so I can look back at it easily. So the x-axis is 30. The y-axis is 0 for D, and then for A, the x-axis is 0 and the y-axis is 30, right? Okay, so average velocity equals to the slope. So I have written the equation for average velocity. You should be familiar of this equation by now, which is average velocity is the rate of change of displacement, and I expanded this equation to be displacement final minus displacement initial, time final minus time initial. Okay, so what is our final displacement? It is 0 minus our initial displacement, which is our y-axis, which is 30, and our final time, which is 0, sorry, it's a 30, and our initial time is a 0. Oh my god, it's still confusing, right? Because the numbers are the same. Okay, so this gives me a negative 30 and over 30. Same, so it's a 1 meter per second, right? That is the unit for velocity. So average velocity equals the slope of the line joining the initial and final position. This is using equation. What if I wanted to use this graph instead to calculate it? Okay, so we draw a line. First of all, we draw a line. Let's use green. We draw a line to connect the two positions, the final and the initial. And then I draw a triangle. I know I'm gonna mess this up, so forgive me. So we have delta y and okay, so I already drew the triangle, and I said, okay, this is delta y and this is delta x. So slope is delta y over delta x, right? Okay, we know this. This is like the basic equation for slope. And delta y means y final minus y initial over x final minus x initial, which is simply our y final 0 minus y initial 30 and x final, which is 30 minus 0, which is the same thing as using the equation, right? So this was using the equation, this was using the graph. So you can do this either way, it's correct, but you need to know what your m stands for. Okay, so here I said, okay, I want to use the graphical method, right? I want to use the triangle to calculate for the slope. And then what is the slope? So the slope is delta y is displacement, which is in meters, and the delta x is in second, which is time, right? So meter per second gives me velocity. So I already know, oh, the slope of this guy is actually velocity. Average velocity to be exact. Okay, so that's one part done. And then we have a third statement saying instantaneous velocity is the tangent or the slope at a specific point. Okay, let's take a look at the slope at point B, for example. So slope is finding the delta y over delta x, right? So let's take a look. B is at this point, so I'm just going to take from here to here because it's basically the same thing. It's the same line. So here I'm just going to say it's at let's say 15 maybe, and this is at 5. So this guy here is 50. So this is at 550. And this point is what? 1550, right? Okay, so let's see. The slope is delta y over delta x. The y is 50 minus 50, and the x is 15 minus 5, which is just 0 basically. So when you have a straight line as the gradient is 0 because the change in y is not there. There's no change in y, so the gradient is 0. Okay, I hope this is clear. And we are on to our next page, which is the velocity time graph. Okay, so the information that you can get from this graph is instantaneous velocity, average acceleration, distance, and displacement. Pretty cool. So when I look at this graph, my y-axis is v, and it should be in meter per second, and this is t, which is in seconds. Okay, and I can I can immediately know that at point P, my velocity is vi, and it happens at time ti. So that is an instantaneous velocity because it is happening at that exact point in time. It's not an average, right? So from a velocity time graph, I can know what is the instantaneous velocity. Next one, average acceleration. The equation for average acceleration is the change in velocity over the change in time. We have seen this as well. When I expand this, this becomes v final minus v initial over time final minus time initial. Okay, so the question asks you, a ball travels from from velocity p to velocity q from time ti to time tf. What is the average acceleration of the ball? So just plug it in. You can use the graphical method, which is drawing a triangle and finding the slope. You can do that, or you can just use the equation. Let's just use the equation, and this is v final. So let's label this first. The v final here is, let's say it's 10, just making it up, and this is a 5, and then I don't want a similar number because it's very confusing to me. So this is a 3, and the velocity is a 2. Okay, so my v final is 5 minus my v initial, which is 2, and I have my time, which is 10, and my initial time, which is 3. Oops, why did I put this? It should be a minus sign, right? Oopsie-doo. Okay, just ignore that. I'm just really bad at using my tablet. Okay, it's drawing. Okay, so this gives me a value for my acceleration. Let's see, 3 over 7 meter per second squared. Why? Because velocity is meter per second, and time is in seconds. So I have 2 seconds now, so it's seconds squared. Okay, so this is your units. So that's your average acceleration. What about the distance or the displacement? How do we find distance and displacement? Remember, our equation for velocity was, our equation for velocity was v equals to what? Displacement over time, right? So if I wanted to find displacement, I just need to rearrange this equation, which gives me displacement is just vt. So v times with t. So if I wanted to find what is the displacement at point P, so I would have to multiply v with t. So we know that v is 2 and t is 3.